Welcome to another deep dive. Today we're going to be tackling something that's super important for anyone just starting out with machine learning,
Absolutely.
getting your data prepped and ready for action.
It is really key.
And we've got some excerpts from a beginner's guide to data preparation.
Awesome.
And we're going to break it down, all the essential steps,
Yeah.
so you can build a really solid foundation
It's like a house.
for your machine learning journey.
Yeah, you need a good foundation.
So this guide starts out talking about data frames.
Okay.
And it uses a really relatable example. It's about predicting house prices
Okay.
based on things like size and number of rooms, how many rooms the house has.
Right.
What exactly is a data frame, though? And why is that so important for organizing our data?
A data frame is like, you can think of it like a spreadsheet,
Okay.
but more powerful.
Okay.
It's this structure that lets you organize your data
Mhm.
into columns and rows, makes it much easier to work with. Each column is like a feature, like house size or number of rooms
Right.
or location. And then each row represents a single instance, like a
Yeah.
specific house.
Okay. So like each row is a house, and then each column is like square footage
Yeah, exactly.
or number of bedrooms.
Exactly.
I gotcha. Okay.
Yeah,
I'm already seeing how this could be super helpful, especially
Yeah.
when you're dealing with tons of different variables.
absolutely.
The guide actually even shows a snippet of code using the pandas library in Python.
Oh, nice.
To create a data frame, it's cool to see how it all comes together like behind the scenes.
Yeah, pandas is like, it's really essential for data manipulation.
Okay.
You can load, clean, transform, analyze data,
Gotcha.
all that good stuff.
So we've got our data loaded into a data frame.
All right.
What's the next step in this whole process?
So now it's time to really get to knowing your data.
Okay.
It's like meeting someone new for the first time, You wouldn't just dive into a conversation without first getting a sense of their personality.
Exactly.
So how do we do that with data? Pandas comes to the rescue with some really handy functions.
Okay. Lay it on me.
So you have a function called describe,
Describe. Okay.
and think of that as a quick personality profile of your data.
Okay.
It gives you key stats like average, minimum, maximum values,
Mm-hmm.
and it gives you this for each of your numerical features.
All right.
This is really good just to get a feel for your data's distribution.
So describe is kind of like getting like a quick bio or something.
Yeah, exactly.
Like, okay, what are the like key traits of this person, this data set?
Exactly. That's a
Okay.
really good way to put it.
Cool. What about actually getting a glimpse of like
Yeah.
their actual story?
Yeah, so for that, we have some other functions like head and tail.
Okay.
And these let you peek at the first few rows or the last few rows of your data frame.
Yeah.
And that gives you a snapshot of what your data actually looks like.
Oh, so it's
Like skimming.
yeah, like skimming the first couple pages.
Yeah, exactly.
And the last couple pages of a book to
Exactly.
get a sense of what it's about.
Yeah, exactly.
All right.
You also have the function info
Mm-hmm.
that tells you about the data types of your columns, like is this a number, a string, a date?
Right.
And then you have shape, which tells you the dimensions.
Oh, okay.
Like how many rows and columns do you have?
So it's like getting that basic information,
Yeah.
like age, profession, hometown
Exactly.
for your data set, basically. Okay.
So that's how you get to know your data.
Sometimes, though,
Yeah.
there are gaps in the story,
Yes.
missing values,
The dreaded missing values.
yes, that we need to address.
Right.
And the guide mentions using isNull for that.
Yes.
What's the big deal about missing values?
Well,
Can we just ignore them?
you can try and ignore them, but it's kind of like trying to solve a puzzle with missing pieces, right?
Yeah, you don't get the full picture.
You don't get the full picture. Exactly. And they can really introduce bias, reduce accuracy,
Gotcha.
and even lead to the wrong conclusions.
So it's like noticing those gaps in someone's story.
Right.
They might not be important, but they could also be hiding something really important.
Exactly. You don't know what you don't know.
Right.
So you really need to take care of them.
There are different ways to handle them, right?
There are a bunch of different ways.
Depending on what the data's like and the problem.
Exactly. It depends on the nature of the data, the problem you're trying to solve.
Okay.
Sometimes you can just replace them with an average.
Mhm.
Sometimes you need to get fancier,
Okay, cool.
So that's missing values.
All right. So we've explored our data. We've looked at those missing values.
Mm-hmm.
The guide then talks about using a heat map for what it calls visual storytelling.
Okay.
What exactly is a heat map, though?
A heat map is a way to visualize correlations in your data
Okay.
between your features and your target variable.
So in this case, if we're trying to predict house prices,
Yeah.
the heat map would show us
It would show you which features.
Which features have the strongest influence on that price?
Exactly.
So like square footage we were talking about before, maybe that has a really strong influence.
Exactly. And you might see that, like, larger houses tend to cost more, right?
Right. Okay.
So there'd be a strong correlation there.
Okay.
And maybe the number of rooms has a weaker correlation. So
Yeah.
more rooms might generally mean a higher price, but maybe there are other things going on.
Right. Right. Okay.
So it really lets you see.
It just helps you visualize those connections.
Exactly.
Okay.
That helps you see the big picture and identify those important features for your model.
But the guide also mentions this thing called multicollinearity.
Ah.
What is that all about?
Multicollinearity is when you have two or more features
Okay.
that are highly correlated with each other.
So like saying the same thing.
Yeah, it's like having two witnesses telling the same story. You might think that's good because you have more evidence, but it can actually make your model worse.
Oh, really?
Yeah.
Oh.
If two features are saying the same thing, one of them might be redundant.
Oh, yeah.
And having too many redundant features,
Mm-hmm.
that just makes your model more complex and potentially less accurate.
Okay. So it's not always a good thing to have a lot of features
It depends.
that are saying the same thing?
It depends on the features.
Gotcha. Okay.
But yeah, you got to watch out for that.
Okay.
Multicollinearity can be a problem.
Man, I'm already seeing how this whole data preparation thing is a lot more nuanced than I initially thought.
It is. It is.
It's not just cleaning and organizing.
No.
It's about understanding.
It's understanding.
Like you said, the relationships between those variables.
Yes.
And making strategic choices
Strategic choices.
to, optimize our data for machine learning.
Exactly. It's all about setting the stage for success.
This is fascinating. We've explored our data.
Yeah.
We've addressed those missing values. We've visualized relationships with a heat map.
We've done a lot.
We've learned about multicollinearity.
Yeah,
Feels like we've already uncovered a wealth of insights just in this first part.
absolutely. And there's much more to come.
Oh, there's more.
Oh, yeah.
Okay. All right.
This is just the beginning.
I can't wait.
We're just getting started.
Awesome. Well, I'm excited to keep going.
Yeah, me too.
I'm sure our listeners are too.
Definitely.
Mhm.
Welcome back to the deep dive.
I'm ready to dive back in.
We left off talking about those relationships between variables.
Yeah. And making some strategic choices.
Where do we go from here?
Yeah. Where do we go?
Well, let's talk about outliers.
Outliers. Okay.
These are data points that are like significantly different from the rest of your data.
Okay.
They can really throw things off.
Oh, okay.
So how do we deal with these outliers? Do we just get rid of them?
Yeah, that's what I was thinking. Can we just toss them out?
Well, not necessarily. Sometimes they can actually be legitimate data points
Okay.
that provide valuable insight, but if they're due to errors or,
Yeah, like if something went wrong.
yeah, anomalies, exactly, then they can really skew your results. That's where these outlier detection techniques come in.
Outlier detection techniques.
The guide mentions something called the IQR method.
IQR method. Okay, what's that all about?
The IQR method helps us define those boundaries
Okay.
for what we consider quote-unquote normal
Oh, okay.
in our data.
So it's like setting a speed limit or something?
Exactly. Anything outside that limit
Yeah.
is flagged as a potential outlier.
Oh, I like that. So it's like those data points that are speeding.
Yeah,
Like, whoa, hold on.
exactly.
We're going too fast.
Exactly. Slow down.
Okay, cool. So we identify those outliers.
Yeah, and once we've identified them,
Mm-hmm.
we got to decide how to handle them.
Yeah.
Sometimes we remove them. Sometimes we adjust them. Sometimes we just leave them.
Right. It's like a case-by-case basis.
Exactly. It depends.
Gotcha.
Now, let's move on to another important step.
Okay.
Data transformation.
Data transformation. Okay.
This is where we make our data machine-friendly.
Okay, because machines don't speak the same language as us.
Exactly.
They want numbers.
Numbers, they love numbers.
Okay.
They struggle with what we call categorical data.
Categorical.
Like location, urban, suburban, rural.
Right. Okay.
We need to turn that into numbers.
So it's like translating a book from one language to another,
That's a great way to put it.
so a new audience can understand it.
Exactly.
Cool.
One popular technique is called one-hot encoding.
One-hot encoding, the guy described it as
Yeah.
giving each category its own spotlight.
Yeah, I like that.
I thought that was a good way to put it.
It's a good visual.
Yeah.
So imagine a column for location.
Okay, location, got it.
With those categories, urban, suburban, rural, one-hot encoding, we create a separate column for each.
Oh,
So instead of one location column, you
Really?
have three.
Okay.
Location urban, location suburban, location rural.
Oh, okay, so it's kind of like breaking it down
Yeah, you break it down.
into its individual components. Yeah.
Exactly. And each of those columns just has a 1 or a 0
Okay,
to indicate whether that category applies.
gotcha. So if the house is urban,
Yeah,
the location urban column would have a 1,
a 1.
And the other two would be 0.
Exactly.
Got it.
Now your machine learning algorithm can understand it.
Okay, very cool. Very cool.
Yeah, so we've tackled those outliers.
Mm-hmm.
We've transformed categorical data.
Yeah, what other data transformations are out there?
Another big one is called normalization.
Normalization, okay.
This is all about leveling the playing field
Leveling the playing field.
for all of your features.
Okay.
So different features can have very different scales, right?
Okay.
Like house size might be measured in square feet, right?
Right.
Which can be hundreds or thousands.
Right.
But number of rooms is usually like 1 to 10.
Right. Completely different.
Different scales, yeah.
Okay.
If we don't normalize, those features with larger scales can really dominate.
Oh,
Even if they're not more important.
Okay, so it's like
Yeah.
we've got a team of athletes
Yeah.
competing in different events.
Exactly.
And we need to normalize their scores so we can actually compare them.
Exactly.
Okay.
So normalization ensures all features have an equal chance
To contribute.
to contribute. Yeah.
Okay.
One common technique is called min-max scaling.
Min-max scaling.
It basically shrinks everything down to a range between 0 and 1.
Okay.
So they all have equal influence.
So it's like turning everyone's score into a percentage.
Yeah, exactly.
So we can compare them.
Exactly. Apples to apples.
Gotcha, okay.
Now let's move on to something even cooler.
Oh, there's more.
Yeah.
Feature engineering?
Feature engineering. Okay, I like the sound of that already. It's like being a detective.
Okay.
But instead of solving crimes,
Right.
you're uncovering hidden patterns in your data.
Okay.
You're creating new features
Oh, okay.
from the existing ones.
So we're not just working with what we've got.
No, we're getting creative.
We're making new stuff.
Exactly. The guide has this really good example.
Okay.
Imagine you have features for house price and number of rooms.
Got it.
You could create a new feature called price per room,
Okay.
just dividing the price by the number of rooms.
Right. Okay.
And that might be even more helpful
Oh,
for predicting prices.
than just using price or number of rooms by itself.
Exactly. It's like taking two pieces of evidence
Yeah.
and putting them together.
To get like a bigger clue.
To get a bigger clue, exactly.
Okay.
So feature engineering, it's all about using your knowledge
Mhm.
and creativity to get more insights.
Very cool.
Now, one last step.
Oh, one last step. All right.
We need to split our data
Okay.
into training and testing sets.
Training and testing. What's that all about?
So this is like having a dress rehearsal before the big performance.
So we don't want our model to see the test data before it's showtime.
We train it on one set of data
Okay.
and then test it on a completely separate set.
That it's never seen before.
It's never seen before yet.
Yeah.
The guide recommends splitting it 80-20.
80-20.
80 for training, 20 for testing.
So it has enough to learn from,
Yeah, enough to learn from.
but also enough to see how well it does.
One new data, exactly.
Okay, very cool, man. This has been really eye-opening.
Yeah, it's cool stuff.
This data preparation, I was thinking it was going to be boring, but it's really not.
It's really not.
It's a lot more strategic than I thought.
Absolutely.
There are so many decisions and techniques.
Mm.
It's wild.
It's all about understanding those nuances, you know?
Yeah, it's not just cleaning and organizing.
It's much more than that.
It's about really understanding it.
Understanding it.
Yeah.
And shaping it into something powerful.
Cool. So we've covered a lot of ground,
We have.
but I'm feeling good,
I'm glad.
feeling confident.
Yeah.
Welcome back to the deep dive. We've spent the last 2 parts really digging into this whole data preparation thing.
It's been quite a journey.
It has. It's the foundation for any good machine learning project, right?
Oh, absolutely. Can't build a house without a foundation.
Exactly.
Yeah.
So we went from loading that data into those data frames
Right.
all the way to transforming variables, handling those outliers.
Yeah, feature engineering.
Oh, and feature engineering. Yeah.
Yeah.
I've got to say, when we started out, I thought this was going to be the boring part.
Yeah, a lot of people think that.
But it's actually been super interesting.
It's really cool once you get into it.
There's so many like strategic decisions you have to make and all these clever techniques.
It's more than just cleaning.
Yeah. It's more than just cleaning and organizing. It's about
It's understanding the data.
understanding it. Yeah.
Yeah.
And its strengths and weaknesses.
And then shaping it.
And then shaping it to be something that's really powerful.
Exactly.
Okay. So let's do a quick recap of what we've covered.
All right.
So we started with loading our data into a data frame. That's that structure, like a super powerful spreadsheet.
Columns and rows.
Yes, columns and rows that lets us organize everything.
Nice and neat.
Yeah, Nice and neat.
And then we did some exploration.
Exploration, right? Getting to know our data.
Using those tools.
Like describe, to get the overview.
Yeah, hence.
To peek at those first and last rows.
And info.
For the data types and structure.
Yeah, got to know what you're working with.
We learned about those heat maps too, right?
Yes, visualizing those relationships.
Visualizing those relationships, seeing those correlations.
Finding those strong connections for our models.
And then there's multicollinearity, which I'd never even heard of before.
Yeah, it's a bit of a mouthful.
It is. But it's important, right? When those features are, like...
highly correlated.
Too correlated, and it can mess things up.
Yeah, too much of the same thing.
Gotcha. And then there are those outliers, the data points that are like...
way out there.
Yeah, way out there.
Throwing things off.
And we learned about that IQR method to...
set those boundaries.
Set those boundaries, like a speed limit.
Exactly.
And then we did some data transformation to make it all machine-friendly.
Right, because machines...
what's numbers?
They love numbers. They don't speak English or,
or any human language.
Any human language, yeah.
Yeah, so we got to translate for them.
One hot encoding.
One hot encoding for those categories.
Giving each category its own column.
Yeah, with the ones and zeros.
And then normalization.
Normalization to level the playing field.
Min-max scaling.
So no feature gets to be too dominant.
Shrinking everything down.
Yeah, to that nice 0 to 1 range.
Makes it fair.
And then, my favorite, feature engineering.
Oh, yeah, that's the fun part.
Where we get to be creative.
Like detectives.
Combining clues.
Uncovering patterns.
Yeah, making new features from the ones we already have.
Exactly.
So cool.
And lastly, splitting our data.
Splitting it, right? Training and testing.
Like a dress rehearsal.
80% for training.
20% for testing.
So our model can practice before the big show.
You got to make sure it performs well.
This has been, like I said, such an eye-opening journey.
I'm glad you enjoyed it.
I really have. Data preparation is way more strategic than I thought.
It really is.
And it can make or break your whole machine learning project.
The foundation is key.
So, for our listeners out there, if you're feeling a little overwhelmed,
don't worry.
There are resources out there to help.
Absolutely.
Scogini offers some fantastic one-on-one training and consultancy.
They're great.
They can help you unlock the power of your data.
For sure.
You can find them at https://www.scogini.com, https://www.scogini.com.
Check them out.
So as you go on your machine learning adventures, remember,
the
quality of your data is everything.
It really is garbage in, garbage out.
So take your time, prepare it well.
Explore it, transform it.
You'll be on your way. Building those amazing machine learning models.
Absolutely.
Thank you for joining us for this deep dive.
It's been a pleasure.
Until next time, keep learning and keep diving deep.